Hi friends, today we can see about Nand2Tetris implementation in computer architecture and organization. Tetris is a game, as we all know. We used to play that one in our childhood in a device. So now we see about how this Tetris game is implemented using NANDs, some logical gates. So in Nand2Tetris we have 12 modules, like 12 projects. These 12 projects include the Nand2Tetris implementation. These 12 components are divided into 6 hardware components and 6 software components. The 6 hardware components are Boolean logic, Boolean arithmetic, sequential logic, machine language, computer architecture, assembler. Software components: virtual machine 1, that is static arithmetic; virtual machine 2, that is program control, high level language; compiler 1, syntax analysis; compiler 2, code generation; operating system. These are all the 12 modules we have in the Nand2Tetris implementation. So we see about first module, that is Boolean logic. Boolean logic is a form of algebra which is centered around 3 sample words known as Boolean operators. We have 3 Boolean operators. They are or, and not. Hardware consists of a few sample building blocks. These are called logic gates. Logic gates are the building blocks of the hardware consist. Example: NAND, or, NOT, NAND, OR, XOR. These are all the logic gates we have. Logic gates are built using transistors. NOT gate can be implemented by single transistor. AND gate requires 3 transistors. Transistors are the fundamental devices. NTM consists of 3 million transistors, and so on. We have 9 million transistors in compact alpha. Now we can build chips with more than 100 million transistors. That is how technology developed. Logical functions can be expressed in several ways. We can represent logical functions in using truth table, logical expression form using circuit. So as we see here, this is the truth table. 3-bit truth table is this one. For this one, the logical expression is f is equal to ab plus bc plus ac. This can be implemented and shown in a circuit form. As we all know, this circuit consists of NOT and AND gates. NOT and OR gates. So our second module is Boolean arithmetic. Boolean arithmetic is also called Boolean algebra, propositional logic, mod 2 arithmetic. These are several names for Boolean arithmetic. The Boolean domain has only 2 values, which we call 0 or 1. Boolean arithmetic means we know computer system will have only zeros and ones. So this is the main thing of the Boolean arithmetic. In other books and articles, they are often called T and F. T and F also called as Boolean arithmetic. So we have here counting systems: rational, representing negative numbers, hexadecimal and binary. Counting numbers is given in this way. Rational numbers means converting decimal, hexadecimal, octal into one number. Representing negative numbers means negative numbers can be converted into a digit using 2's complement. Here we have the 2's complement. Example: 2 minus 5. 2 is represented as 0010 in 4 bits. 5 is represented as 1011. If we add these two, we will get actually minus 5 we have. So the value of plus 5 we will take. The value of minus 5 we will take and we will add. Minus 5 value will be coming by taking the value of 5 plus 5 and convert zeros to ones and ones to zeros and add plus 1 to it. Thus 1011 is given. So when So this is how representing negative numbers is done. Hexadecimal and binary, decimal, hexadecimal and binary. We have 1 to 15 in decimal. Hexadecimal have 0 to 9 and A, B, C, D, E, F. Binary means we will represent them in zeros, one in binary form like zeros and ones. So building an adder, a chip designed to add two integers. A chip designed to add two integers is an adder. Proposed implementation: half adder, full adder, and bit adder. We have half adder and full adder and n bit adder. In half adder we use two gates. In full adder is designed to add 3 bits. N bit adder is designed to add 2 n bits. This is how the half adder, full adder and n bit adder are implemented. You can search in net about this one. You will get the clear explanation of this. The arithmetical logical unit. Hack platform, logic hack platform, ALU in CPU content. Here we have hack platform, we have half adder, full adder and 16-bit adder. ALU is arithmetic logical unit. ALU stands for arithmetic logical unit. So this is what the ALU is. So ALU in CPU content. In CPU, how the ALU is done, that is clearly shown in this figure. ALU is here. Register, mux means multiplexer, another register, RAM. This is how the ALU is stored in CPU. Sequential logic is the third module. As we know, sequential logic is a type of logical circuit whose output depends not only on the present value of its input signal but on the sequence of past inputs, the input history as well. Operation on data and clock signal as such can be made to be state aware and provide storage and synchronous services. In sequential logic, we have the clock, flip-flop, bit register, multi-bit register. These all will come under sequential logic. Random access memory. Random access memory is nothing but RAM. In here we have RAM interface, RAM and anatomy. As we know, RAM have read logic and write logic. We can read from the RAM and we can write in the RAM. This is how the RAM looks like. RAM interface is here. RAM will be there. If you write anything, it will come out. The input and the output will have same bits. We will load the things here. Address is given here. And then RAM anatomy. Registers are there. These registers are stored in RAM, and RAM is made up of these type of registers consisting in RAM are stored in RAM 8. If this is 8 register RAM, then 64 will be 8 into 8 is equal to 64. Machine language. Machine language is a fine line where hardware and software meet. Programming in machine language is tedious. Instead, use a low-level symbolic language that is translated to machine language by assembler. Machine language is an agreed-upon formalization which manipulates memory using a processor and a set of registers. So here we have memory. In memory we have memory address. M is also an address. Processor, CPU, registers. Registers are high-speed local memory to the processor. So these are all the commands: hack machine language, flow control, memory access, direct addressing, immediate addressing. These are the addressing modes on the memory. Flow control, branching. Hack machine language means machine language. And computer architecture. Computer architecture is a specification dealing how a set of software and hardware technology stands interact with a computer system or a platform. In short, computer architecture refers to how a computer system is designed and what technologies it is compatible with. In computer architecture, we have hack computer, memory, CPU implementation. Memory is nothing but physical implementation. Hack computer is a 16-bit one unit platform. Main parts of the hack computer are instruction memory, CPU, computer. This is the memory. This is the CPU implementation. This is the chip diagram of the CPU implementation. Assembler. An assembler is a program that converts assembly language into machine code. It takes the basic commands and operations from assembly code and converts them into binary code that can be recognized by a specific type of processor. Hack assembly, some constant level. Examples of assembler: implement an assembler. This is the implementation like algorithm for hack. Constant labels are label value. Here are the some constant labels for the implementation of hack assembly. Examples of assembler. Here we have some examples of assembler. Implement an assembler. For implementing an assembler, this is the algorithm given. So as of now, we completed Boolean logic, Boolean arithmetic, sequential logic, machine language, computer architecture, and assembler. These are the 6 hardware components in Nand2Tetris implementation. So this is what the hardware components in Nand2Tetris implementation. In next video, we will see about software components in Nand2Tetris implementation. Thank you.